guys, it's Mrs. Paulk, and today we're going to be talking about the scientific method, independent and dependent variables, and we're also going to talk about scientific laws and theories. Okay, so here is an outline of what the scientific method typically looks like. When we start the scientific method, we start with an observation. Then leads us to a question. Our question leads us to some research. We form a hypothesis, we do an experiment, do some data collection, and come to a conclusion. On the next slide is where we start your notes. So please make sure you have your note sheet with you. If you need it, it's on Google Classroom. So the scientific method is something that we use to answer questions. It helps us stay organized and plan for gathering, have an organized plan for gathering, organizing, and communicating information. And that's known as the scientific method. So this process in which people who do science experiments, the scientists, they gather information, organize it, and communicate the information, the entire process is called the scientific method. If you need a moment, go ahead and pause the video and restart when you're ready. So like I said, your first step, make an observation. So you might notice that, your car won't start or something like that. So you observe something and then you continue on through the scientific method. You ask the question, well, why won't the car start? And after you ask your question, you're going to develop a hypothesis, such as if the car doesn't start, then the battery is dead. Okay, so that is my hypothesis. If the car doesn't start, then my battery is dead. We're going to test the hypothesis with an experiment. So I might go and get the machine that tests the voltage of the battery, or I might just try replacing the battery as a whole. Okay, so I'm going to, whatever my hypothesis is, however I want to test it, I'm going to test it one way. So let's say I think that it's because my battery, and I'm going to test the voltage. So I test the voltage, that is my experiment. I analyze the data from that experiment, so the data that I will get from that experiment from testing the battery will be, is the voltage high enough or is the voltage too low? My hypothesis was if the car doesn't start, then the battery is dead. So if the battery is dead, that means my hypothesis is supported. I would go one way. And if my battery was not completely dead and it should still work, I would go with the hypothesis is not supported. Now, depending on which of these two answers you pick, you'll go a different route. So let's say, yes, my battery is dead, that I test my hypothesis for further experiments. Maybe you might not need to in this case, and then you would finalize your information. If it turned out the battery was fine, then I had to go back and develop a new hypothesis and go through the process again. Typically, when the hypothesis is supported, eventually it will go into a theory, but that's after many, many rounds of this. It doesn't just go automatically to a theory. Starting an investigation. Scientific investigations often begin with observations. An observation is info that you obtain through your senses. An inference is what we make of an observation. A hypothesis is a well-thought proposed answer to a question. So these observations are what we gather through our five senses. We talked about those in the last video. We also talked about inference in our last video. Okay, that's the prediction or assumption you make based on your observations. Alright, so we already talked about those two words. The word that we haven't talked about in class is a hypothesis. And a hypothesis is a question that you have to really, really think about. You can't just it's just not like a willy-nilly question. And it's usually stated in an if-then statement. Types of variables. So we have something called the independent variable, which causes change. So if you change the independent variable, it will change the outcome. So for example, the sun affects plant growth heights. The sun is an independent variable in this case. The dependent variable changes in response to the independent variable. So the amount of sunlight will make the plant, the sunflower, grow to a certain height. So that height depends on how much sun the flower gets. A controlled experiment is an experiment where all conditions stay the same but one. So you only are changing one thing. In this case, would be changing the amount of sunlight. If I were to also change the soil type, the plant type, the amount of water, and so on, it would not be controlled. Okay, when you have a controlled experiment, you only change one element. Everything else stays the same. A control is a standard sample used to compare the results. So we have something set up at a specific way, and that is our control. We don't change anything in the control. Then what we do in the other plans is change one thing and compare those plants together. So here's another picture explaining independent and dependent variables. In this picture, we are explaining independent, the one thing you change, limit to only one in an experiment. For example, the liquid used to water each plant. So here it looks like we have a can of cola water in the plant. Over here we have juice, and over here we have water. Okay, so these three things are example of the independent variable. Okay, it's the one thing we've changed. The dependent variable is the change that happens because of the independent variable. So it's what is changing based on this independent variable, the thing that we changed over here. So for example, the height or health of the plant. When I watered it with cola, how the plant likes cola is going to affect the tallness. Same thing with the juice and same thing with the water. Controlled. Everything you want to remain constant and unchanging. So the type of plant used, the pot size, amount of liquid, and the soil type. So this is showing that the plant is controlled and everything inside the pot is also controlled. Alright, so now we're going to go ahead and skip on to scientific laws and theories. It's on the same set of notes, so just continue on with me. I believe it's on the back side. So scientific laws and theories. A scientific law is a proven statement that summarizes a pattern found in nature. Theories explain a cause and effect relationship using data. It's important to note that laws do not often change, but theories may. I'm going to go over examples of a scientific law and a theory, so you kind of recognize those in just a moment. If you need more time, go ahead and pause and move on when you're ready. So the law of gravitation. The gravitational pull of objects on each other can be calculated using Newton's gravity formula. So the law of gravitation is it is very unlikely to change. We experience it all the time through our world and the gravitational pull. The Big Bang Theory states that all matter in the universe was created after a massive explosion about 4.5 billion years ago. So since this is a theory, that it can adjust and change over time as we find new and more information. So here is a little chart for you guys to fill in. I have a column for theories and a column for laws. I'm going to start with theories first. So theories are based on observations. They are testable explanations that have not been proven and have evidence to back the claim. Laws, on the other hand, are based on facts. They have been proven and they have evidence and results to support the proof. Go ahead and pause if you need to and then continue when you're ready. So here's some examples of forming a hypothesis. You notice baby's crying, so you could say if the baby is crying, then it needs a diaper change. That would be a hypothesis. It might need a diaper change. If your wallet is missing, maybe then it got stolen. If the plant is dying, it did not get enough water. And if your car is not starting, maybe you forgot to put gas in it. All right, so assessment question. A hypothesis is a semi-good conclusion in an experiment. B, a well thought out proposed answer to a solution. C, a well guessed proposed answer to a solution. And D, a well thought out conclusion in a science experiment. If you chose B, a well thought proposed answer to a solution, you are correct. The difference between a theory and a law is that blank. A, laws are proven in ways that theories are not. Theories are not reliable conclusions. Theories are about patterns in nature, And D, laws are not peer reviewed. If you said A, laws are proven in ways that a theory are not, you would be correct. Alright guys, I hope you have a great day. If you have any questions, let me know in class, and I hope to see you soon. Bye.